Hi, Chance. We'll get started in just a few. We'll get started in about 2 minutes. Thanks for your patience. All right, thanks for your patience. We're going to go ahead and get started. So let me go ahead and share my screen. Okay, so could somebody unmute for me and tell me if you're seeing the course page?
Yes, ma'am.
Okay, thank you. So let me go into the announcements because I did have an announcement that I want to make sure everybody sees. So of course, I've been posting the videos for each class period. So the video from last Wednesday is definitely out there for you. I apologize that it takes me about a day or so to get it captioned and then get it out there for you, but it's available if you need it. Also, I posted an announcement regarding the discussions that have been taking place. So, I've had an opportunity to kind of get caught up with some of the grading for this class, in particular the discussions. And well, put it this way, the responses for a good number of students haven't been as detailed as I would have liked. And so in my mind, that means maybe I need to spend a minute making sure everybody understands the instructions clearly. So first of all, for every discussion, you're supposed to answer the questions thoroughly on your own, meaning if it's a question that you have to type out a written response to, it needs to be thorough. If it is a problem that you need to solve, you should do more than just post the answer. You should also show all of your work. Now, there are some of you that have been doing that, and that's great, but there are a good number of you who have simply been posting things like, I like your answer, or good answer, or we both got the same thing, or without much beyond that, without explaining why you think an answer is correct or why you like an answer, or digging a little bit deeper, even if you got the same answer. How did they solve it versus how did you solve it? Something to show that you are trying to have a more engaged conversation, trying to create the effect of being in the same space together, having an actual discussion and working the problems together, right? And so what's been happening is that the people have been posting these short, brief responses and not really engaging each other. And that is not the intent of the discussions, okay? And so it, just like it means I needed to spend a minute making sure that everybody understands the directions. It also means that I need to make sure that everybody understands that from this point forward, when I start grading the discussions that are going to be completed this weekend, I'm not going to cut you slack on that, okay? I'm not going to accept the fact that you just put out a short response, or you don't show your work, or your answer is not thorough. If it's a kind of a essay type of question where you have to type out a written response as opposed to solving the problem. I expect that you will, put some thought into how you respond to your classmates.
Right, yeah, here, let me just.
Hello? Okay, so thank you for muting. I appreciate that. So as I was saying, what I want you to get away from is these short responses that don't really show any real effort to engage with your classmates. And if that's the kind of response you post from this point forward, is going to cost you points. Okay. And the scoring rubric is available in the syllabus. It's also available if you click on the left menu, assignments and activities. There's a link that says post labs, and it explains totally what the expectation is for the discussions. So please take a moment, make sure you're comfortable with that, because you know, from this point forward, I'm going to hold you accountable to have a robust discussion with your classmates on these questions that I'm posing to you in those post-lab discussion activities. Okay, so are there any questions about that? All right, so I think with that, I can go ahead and, you know, go into this week's material. Excuse me. So just as a reminder, you know, we're getting closer to the time when you need to be having your project article approved. Okay, so just to kind of refresh you on what you do to get your article approved, because I did cover this, you need to send me the full article as a PDF file, right? Attach it to an email and send it to me. So when you find articles that you potentially want to use for the project, you have to get it approved. And to get it approved, you have to email it to me. You have to email me the full article. And you have until the 23rd of October. So, you know, it looks like, well, you got a lot of time, but actually your time is getting shorter and shorter to get an article approved. And those of you who have already received approval for your articles, I commend you for getting it done early so that you have, you know, adequate time to read the article and really digest it as best as you can for these complicated kinds of articles that you're dealing with to complete this project. So, you know, don't delay. The sooner you get it in, the sooner you can get that off your plate, because if you don't get an approved article by the 23rd of October, I'm not going to cut you any slack on that, and you'll lose 20 points on your project score. Okay. So, any questions about that? All right. So that takes care of that other important thing that I needed to remind you about. And so now we can definitely go in and get to today's material. So this week, week 7, we're dealing with Newton's laws. This is a topic that we've already covered in lecture. So, you know, I always kind of like to, you know, my hope is that I can cover something in lecture and then we can do an experiment in lab, right? So you have adequate background if you're in lecture with me before you have to tackle the experiment, right? So this week, your experiment deals with Newton's laws. And the whole idea is for you to get familiar with what are Newton's laws, how do we use those laws to help us understand the behavior of forces when they come into play in terms of motion. You're going to be looking at things like friction and looking at how it affects motion. So, you know, this is a real, you know, this experiment is getting really starting to get much deeper into the concepts and to the application of the concepts than you have had to deal with before, right? Because once we get to Newton's laws, you're dealing with a much more complete picture of motion, because not only are you dealing with kinematics like we did with the 1D and 2D motion labs, you're looking at the causes for changes in motion, right? And so that makes this much more detailed in terms of what you're expected to be able to do. Okay, so that's what all of this long laundry list of objectives you know, describe the kinds of things you should know and be able to apply regarding Newton's laws. All right. So of course, it goes without saying, you have some activities on your plate that you have to complete by this Saturday. And the first one of them is the experiment that we'll look at in just a moment. Then after you complete the experiment, you write a lab report. And then after you do the lab report, then you do the post-lab discussion. And so we'll look at all of those in just a moment. Just to remind you that I always make available material to help you with the topic areas that we're covering. And so chapter 5 in the CK12 textbook, which we use for lecture class, is available here. It deals with Newton's laws. There's some videos, and then there's a NASA, I do believe, yeah, this handout here is a NASA handout that looks particularly at Newton's second law. So you have some resources there to help you if you need to, really refresh yourself regarding Newton's laws. If it's been, a semester or so since you've seen them, or even if you have me for lecture class, it doesn't hurt to take a look at the items in the in this section before you start the experiment to make sure that, concepts are fresh in your mind. And of course, if you don't have me for lecture, then I don't know what you're doing. And so I always like to make sure that you have adequate support resources to tackle the topic area, right? So my suggestion to you is take a look at these readings and viewings first, and then go and tackle the experiment, the lab report, and the post-lab, okay? And of course, I always remind you that under useful links, there are some additional resources that you can pull from if you need to tackle this topic. You see, there are some, there's a tutorial site, there's some other free textbooks that, you might find useful in this situation, okay? But, I always tell students, if you don't like the materials that I put in the weekly overview, and you don't like the materials that I put under useful links, you can Google Newton's laws. You'll find a gazillion websites, okay? All right, any questions on where we're going with this now? All right, so let's take a look at the experiment handout. Okay, so yeah, of course, I always put the objectives in the handout so you know exactly what the expectation is. When you complete this handout, those are the things that you should be able to understand, know, and do regarding Newton's laws. Before you get started doing the simulation, to make sure that you have a foundation to operate from, spend a moment, use the resources that I provided, and define those 6 items there. What are Newton's first, second, and third law? What's friction in general? What is static friction and what is kinetic friction, right? Having those definitions, and not just any simple, short kind of, let me just do something definitions. Spend a minute and really try to give a thorough definition, because it's going to help you when you get into the actual simulation, okay? So make sure you write out a definition for each of those items before you start, okay? Then what you want to do is you want to go ahead and get into the simulator. Okay, so here we go. So, go ahead out to that simulator website. And then to get it to start, you have to click the play button. Okay, and you can see that there are various settings that you can use. If it were me, I would actually try to, I would try all of the different settings and see what, what things can I do with each at each setting? What's different about each setting? That kind of thing. So I always advocate turning on all the bells and whistles, and then you pick some players, okay, and you can see here if the blue is person is pulling with 50 newtons to the left, and the red person is pulling with 100 newtons to the right, the red person is going to win. And the net force, or the sum of the forces, or the resultant force, is 50 newtons to the right. Well, that's pretty straightforward to understand. I mean, I'm sure at some point in life you've heard of the concept of a tug of war, and whoever pulls with the most force wins, right? So then you can hit go, and you can see how the speed of that cart changes because you have an unbalanced force. And so you accelerate or change the speed, right? And you change the speed in the direction of the larger force or in the direction of the net force, okay? And so all of the various settings have something similar to that concept, whether it's, you know, a refrigerator on top of a box, or, and then, you know, you can, you know, push with a certain amount of newtons, or, you know, and you see, right? So turn on all of the bells and whistles, as I like to call them, and see what happens as you adjust things, right? So you get yourself familiar with what goes on in each of these different settings, and how the bells and whistles work, and how you manipulate the people or the boxes or the presents or whatever it is they have available in that setting. And then once you're comfortable with that, then go back to the experiment handout, and it'll tell you what setting you need to use. So it says for part 1, you're going to use the friction tab, right? So you see there's a tab that says friction, okay? And so you'll need to be familiar with how things work under this tab, because they're going to ask you to do a series of, you know, steps, a procedure. You follow the procedure under that section, you complete the table, tells you to plot a graph. Hey, here's another opportunity to get some practice with graphing, right? Because as I mentioned to you before, the graph in this case will be used to do what? Share your experimental data. So they ask you to make a graph, and I will be looking to see that your graph is done using proper graphing technique, right? So graph paper, you label your axes, you put units on your axes, your graph has a title. If it's linear, which it is, because they tell you to find the slope, you show your slope calculation on the graph. You know, all of those things that you were supposed to master in experiment number 2 on graphing. So now you have to use that to complete this particular experiment. All right. And so, you know, you're gonna do that, you know, procedure in part 2, except you're gonna be on the acceleration screen. Okay. So you see there's an acceleration screen, and then you turn on all the bells and whistles, and then you follow whatever procedure they're telling you here. You complete the table, okay? And then it asks you to plot a graph. And look here, even in step G, it asks you to find the percent error of the mass. Now, I always get the question, well, what's my correct mass? Because, you know, if you're gonna do percent error, right, you have to have what? You have to have your value and a correct value. Well, a correct value is what's given in the table, okay? And so then if you follow the procedure and you understand Newton's laws, then you'll be able to figure out what's your mass, right? And then once you finish that, this portion, it asks you to write a conclusion. And actually that conclusion is the same one that you can utilize for the lab report. So you can either put it here or you can put it in your lab report, because you know, this completed experiment handout gets turned in as part of the lab report, okay? So do any of you have any questions about the expectation regarding the experiment itself? Okay, so that either means I've explained it really well or y'all have tuned me out. Oh, no, I can't do that. All right, so we just went over the experiment. Now let's talk about what goes in the lab report. Same old standard, typical format for a lab report, except let me just be very clear with you. I'm going to look at this one a little bit closer than the ones you've written in the past. You've got your feet wet. I've given comments, feedback, that kind of thing on several, you know, assignments that you've done for me. And I've discussed on multiple occasions the kinds of things that you put in an abstract, and it's even itemized for you here, the kinds of things you need to be putting in your abstract. Remember, the abstract has to be detailed enough so that somebody can take your abstract and redo the experiment. And they, you know, even if they have no idea about what this class is about, if you gave them your abstract, they know what website to go to, what procedure to follow, what data should they be collecting, and what are they going to do with that data, and why they're doing all of this, okay? And then under what you found, remember, in this particular experiment, not only do you have to explain something that you figured out when using the simulator, something that you figured out. If I change this, this is what happens to this while you're using the simulator. You have to be able to answer that type of question. But also you have a percent error calculation here, right? So you should be able to tell me how good of an experiment you think you did in part number 2, because you completed a percent error calculation in part number 2. And remember, the size of the percent error is not what I'm looking. I'm not going to grade you based on the size of your percent error, but I will take points if you don't tell me, you know, if you don't do the percent error calculation and then you don't discuss it under what you found. Okay. So any questions about this particular abstract that you're going to have to write? Okay. Because you've had a few times to practice this. So now I can really start to hold your feet to the fire on what I'm looking for.
Can you repeat the error part again, please?
Yes. So in the experiment handout, in part number 2, one of the questions asked you to calculate the percent error in the mass. And remember, I told you the mass value that's in the table is the correct value, and you're going to get your value from the experiment, right? And if you understand Newton's laws, you'll be able to find the mass fairly easily and compare it to the mass that's in the table using a percent error calculation. Well, under what you found, it asked you to discuss the quality of your data based on the size of the percent error values. And this time you have one. You only have 1% error calculation, but you can definitely tell me, hey, I think I did a pretty good job in part number 2 because my percent error is, you fill in the blank, okay? And so you make the decision. And as I said, I won't take points if your percent error is big or small. But what I will take points for is you didn't do the percent error calculation like I asked you to. And number 2, you didn't discuss your percent error in the what you found section of the abstract. Okay, so does that make sense to you?
Yes, ma'am. Thank you.
Okay, so you know, in this what you found section, you have to discuss your percent error, and you have to talk to me about what you figured out when using the simulator. Okay, all right. And then the data and analysis portion of the lab report, that's your completed experiment handout. So everything you filled in on the experiment handout, all of the questions that you answered, the graphs that you did, all of that goes under data and analysis. Okay. And then finally, the conclusion, as I said, tell me what you learned, not what you did with the simulator. So tell me something that you learned about Newton's laws that you didn't know when you started this experiment. Okay. All right. So are there any questions about what you should include for your data and analysis, or what you should do for the conclusion? All right, let's go back. And then the last thing that you have to do is post-lab discussion. So I have a series of questions here that relate to Newton's laws. You have to answer these questions first, and then you have to reply to 2 of your classmates. And it tells you very clearly here, you know, that I'm looking for, you know, a genuine effort to engage. I'm looking to see that you're really trying to have a discussion with your classmates. And you're not just posting some simple, you know, I agree or I like your answers without really delving to explain why. Or if you don't agree with their answer, do you know, write more than I think your answer is wrong, but you don't really go into detail about why they're wrong. again, the idea of these discussions is to try as much as possible to create the feel like you would have if we were all in the classroom together. If we were all in the classroom together, then I would break you down in teams, or you would break down in teams, and each team would take time to work together to answer these questions. So each person would turn in their own answers to the questions, but you would work with each other to try to figure out what the answers are. And if you're working in groups, inevitably, one person's going to do something and somebody's going to do something different. And then you have to decide, well, which one of us is correct? You know, or why, how did you figure that out? Why did you think that? And you have to discuss it out until you figure out, okay, well, I think, you know, I think you're right, or I think I'm right. And then, you know, you have to make a judgment call about how you want to go with the answer. And then everybody turns in their own work. So if we're in class, you work in groups to do these questions. Well, we can't be in the classroom together because this is an online class, right? But you can have a discussion where you post your answers and then you critique what other people have posted, right? And so you can have a bit of back and forth with them. Hey, I think you did the 5th question. That doesn't look correct because, and here's what I think, okay? Now, you know, please respond back and tell me what you think about what I posted, okay? And then you kind of work together with each other. So I'm going to be looking to see that you actually attempt to do that on this discussion and every discussion going forward, okay? As I posted in the announcements and I discussed at the beginning of class, you know, I've been pretty much kind of being lenient in my scoring because I recognize that, you know, some students were still getting acclimated because of the large adjustment that's you know, we've had to endure because of the storm, right? But now we're at a point in the class where, okay, you know, hopefully everybody's had an opportunity to really kind of, you know, get their feet wet, so to speak. And now you're in it full, you know, up to your, you know, you're in it now. And so we gotta, you know, try to do due diligence to this stuff from this point forward. And so I gotta hold you a little bit more accountable for what you're posting in these discussions, because otherwise you'll walk away not really having a strong picture of this, you know, this physics that you're supposed to be learning. And Newton's laws is a great place to do that, because now you should have enough of the basic concepts under your belt: measurement, error, graphing, and some basic introductory kinematics and motion concepts that you can make heads or tails of this stuff now, and really, you know, really give a more deeper and thorough answer to these types of questions. All right. So, any questions about the discussions and you know what I'm looking for? All right. So the only other thing that I'll remind you of in the weekly overviews is that this lab report submission instructions remind you how to turn things into me. I'm starting to get more and more emails with files that are not in the proper format, or I'm getting emails, how do I turn this in? I couldn't upload it on Canvas. All those kinds of things that are clearly explained in this lab report submission instructions. And that document is available in every weekly overview. And it's also available on this left menu under assignments and activities. And then finally, if you're working this week and you have questions, you can drop a line in the class questions forum. You shoot me an email or come to office hours. You know, I'll be happy to address any questions that you might have. All right. So one last time, do you have any questions for me?
Yes. So is there only one lab? Because I joined late. I don't know if we had a second lab.
No,
You
sir.
went over.
Yeah, in the weekly overviews, this one is the only one that's listed for this week. So if you just scroll down there, you see we're week 7. Here we are, Newton's laws, right? I mentioned this to you guys earlier too. You know, in the first couple of weeks, we were really trying to get caught up, right? Because we had to postpone classes and everything and things. We basically had to start over, right? And so that also is why I hadn't been as rigid in my scoring and grading with you because, I wanted to give folk opportunity to get caught up, right? Get caught up without, me being so difficult about it, right? Because I know that I needed to be a little bit flexible, but we're at a point now where, we're going to be dealing with some major concepts now that you really need to get a thorough understanding of to say that you really understand physical science lab, okay? And so, so we got to buckle down a little bit. But no, it also means now that we're caught up, we don't have to do 2 and 3 experiments every single time. There'll be some times in the future where you'll have a couple on your plate, to be honest with you. But, we can spread things out a little bit more and give you a little bit of breathing room so you can not be so, so bogged down with a whole bunch of stuff every weekend. That makes sense?
Yes, ma'am. Thank you.
Not a problem. Any other questions? Please don't hesitate to ask. Just unmute, ask your question. I'll be happy to answer. All right, so if there are no questions, let me stop share. That is about it. I'll hang around here for a little while. But if you don't have any questions for me, we're actually all done.
Thank you. Have a good day.
You do the same. Hi, Connor, did you have a question for me? Connor, if you aren't able to utilize a microphone and you have a question, just type it in the chat. I'll be happy to answer.